Are you frustrated when sorting a list on your work? Feeling tired of repeating using a slow sorting method? Are you hoping for a better solution? Worry no more. A one-of-a-kind solutions to all your problems. An algorithm comes with a hybrid algorithm effective for real-world data and adaptability and memory efficiency. Hi, I am JAYSON BALBIRAN.
And I am JUDY ACQUIATAN.
I am FAHMIA BILAY.
I am May Mendoza Subiaco.
And we introduce to you the TeamSort algorithm.
So what is TeamSort algorithm? TeamSort is a powerful sorting algorithm combines the strengths of both merging and assertion sort to deliver efficient result. While originally developed by Team Peter for Python in 2002, it has been adopted by other languages like Java and C++ due to its effectiveness. TeamSort is a combination sorting algorithm that combines the advantage of insertion sort and merge sort, two distinct sorting methods. While insertion sort is a straightforward sorting method that works well for small arrays, merge sort is a divide and conquer strategy that works well for large arrays. Team uses merge sort to arrange the incoming data into large subarrays and insertion sort to arrange the remaining smaller subarrays. So TeamSort combination of approaches makes it effective for both small and large data arrays. So TeamSort doesn't require extra storage space because it is an in-place sorting method. This can be beneficial advantages for large data sets. And all things considered, the TeamSort sorting algorithm is robust and flexible, performing well in a variety of scenarios. Team is a hybrid sorting technique used in a Python, Scala, and Java. It efficiently sorts large arrays of data by combining insertion sort and merge sort, a divide and conquer strategy, into a big subarrays. This efficient approach works well for both small and large data arrays. Since TeamSort is an in-place sorting algorithm, no extra storage space is needed. For vast arrays of data, this can be a very useful benefit. All things considered, TeamSort is a strong and adaptable sorting algorithm that works well in a wide range of situations. For good reason, it is a Java default sorting algorithm. It is fast, flexible, reliable, and in place. Overall, TeamSort is a powerful and versatile sorting algorithm that is well suited for a wide variety of applications. However, it is important to be aware of its limitations before using it in production environment.
This table is a time complexity for the short case in TeamSort algorithm. When the input array has been partially sorted, the base case time complexity for the TeamSort algorithm is O(n). In this situation, the execution time increases linearly with the amount of input due to effective findings and combining of the sorted runs by TeamSort. Average case. TeamSort has an average case time complexity of O(n) log(n). When the input array is dispersed randomly, this happens. TeamSort balances the complications using the hybrid solution that chooses merge sort for bigger runs and insertion sort for the smaller subarrays, yielding an average case time complexity of O(n) log(n), which happens when the input array is in reverse order in O(n) log(n). In this situation, the worst case time complexity is O(n) log(n) since TeamSort merging operation requires more time to reorder the elements. So this is the advantages and challenges of TeamSort algorithm. First, effective for real-world data. TeamSort works effectively in real-world circumstances where the input data may not be evenly distributed because of its versatility. Second, stable cert. Team cert stability make it a good option when it comes to application where maintaining the order of equal components is crucial. Third, low overhead. One factor in TeamCert overall efficiency, it is comparatively low overhead when compared to other certain algorithms.
Limitations and challenges. TeamSort is a powerful algorithm with a hybrid nature, requiring more development effort, potential performance dips, and specialized tasks, making it a champion with implementations challenges. In limitations and challenge, TeamSort has many great features, but it also has a drawbacks and issues that need to be taken into mind. These include implementation complexity, overhead, worst-case performance, and additional specialized sorting duties. TeamSort is more difficult to construct than a simpler algorithms like bubble sort because of its hybrid methodology and internal data structures. More work and knowledge and development may be needed for this.
While TeamSort is widely known as the other sorting algorithms like the merge search or the quick sort, which actually used in several popular apps and software platforms due to its efficiency and adaptability to the real-world data. Here are the examples of these are such as Google Chrome, Microsoft Word, Excel, Google Sheets, ordering app, and some of the LRRC system in different colleges and universities. Hi there, I am JAYSON as BALBIRAN but an animated version. And now we will see a Java program using a TeamSort algorithm using a real-world data scenario. As you can see, here is the running program. Consider yourself a teacher who has a list of students along with the result of their tests. The students' list should be sorted by name and exam score. We name it Student Name and Exam Score TeamSort Program. In below, choose sorting criteria. So there are two types of sorting criteria. Sort by score, which is ranking, and second, sort by name, which is alphabetical. While the third option is to end the program. First, we will try the sorting criteria, which is the sort by name, which is alphabetical. So enter your choice. So we input 2. Then enter the number of students. So we input 4 students. So enter the name of student 1. We will type BALBIRAN. Next, the exam score of student 1, which is 87. So student 2, SOBIACO. Exam score of student 2, 85. And the student 3 is BILAY. Then the exam score of BILAY is, we type 91. Then student 4 is ACQUIATAN. Then the exam score is 89. So the final sorted student records by name, which is alphabetical arrangement. So the first is ACQUIATAN with the exam score of 89, followed by BALBIRAN with 87, followed by BILAY with 91, and last is SOBIACO with 85. And now we will try the second sorting criteria, which is the sort by score or ranking. Now we will enter your choice. We will input 1 and enter the same names and students. So enter the number of students, which is 4. So enter the name of student number 1, BALBIRAN. The exam score of student number 1, 87. The name of student 2, SOBIACO. The exam score of student number 2 is 85. Student 3, we type BILAY. Then the score is 91. Then the student 4 is ACQUIATAN. Then the exam score of student 4 is 89. So the final sorted score records by score ranking. So rank number 1, we have BILAY with the exam score of 91. Rank number 2, we have ACQUIATAN with 89. Rank number 3, we have BALBIRAN with 87. And rank number 4, we have SOBIACO with 85. The behind of this successful sorted outputs is team sort algorithm. So students are sorted within each name a category first by name and then by score, or the opposite by ranking the score. Team sort is a strong sorting algorithm that can effectively and precisely handle this task. It is perfect for sorting student records because it can handle big data sets. And now I will discover the Java code program using the team sort algorithm, and we will witness which part of the code does this team sort algorithm works. As you can see in our Java code, in the upper part, we have the import java.util.asterisk and a public class named teamSortExam. So we have a static class of student that implements comparable, and also another class of student with a parameter of string name and int example. So there are different types of method that has been used. So we have the get name, get exam score, get rank, and set rank. So we have a public int to compare to student others. So in this part, this is where the team sort works. So the student class implement compare interface providing a compare to method that defines a comparison of logic and sort for sorting. As you see, we use the compare to method. So in this part, we also use if else and return statement. All data will be gone through in this code. So each code, if you select score, so all score comparison by their integer. Each data will be compared to another data. If you don't select the scoring or ranking method, then it will return to this name and compare each name and character. To run the identification, TeamSort internally identifies naturally ordered subsequences within the array. As you can see, the potential forming of run based on the equal scores. While not explicitly shown in the code, this run identification is to kill TeamSort efficiency. So as you can see also here, we have the merge sort integration. In this part, the TeamSort then utilizes a modified version of merge sort to combine this run efficiently. The array.sort call triggers in this internal merge sort mechanism, leveraging the TeamSort's optimized and merging technique. And this part where is the final output has been processed. So the below code has been display the sorting criteria, such as choosing the sorting criteria that you have. We use a switch case from this part. So we have a case 1 for the sort by score, and case 2 to sort by score. If false, then it will sort by names. Then we have a case 3, which is to exit the program. So if none of those cases, then it will directly to default. In this part, this code defines a method called sort and display student that takes a scanner object as input. So this is where the part to get the number of student. So we use the method that first prompt the users to enter the number of student and stores the value in the number student variable. The method also creates an array of student objects called students with a size equal to num students. So in this part, the code iterates or the method through the students array and prompt the user to enter the name and exam score for each student. The entered information is used to create a new student object and store it in the corresponding element of the students array. In that, it uses an array sort method to sort the students array based on the chosen criteria. The criteria can be either student's name ascending order or by exam scores. If the student were sorted by exam score, the method iterates through the students array again and assigns rank to each student based on their position in the sorted array. So finally, the method iterates through the students array and prints the name and exam score if rank of each student. And now let's proceed to the TeamSort algorithm simulation based from our Java program. As you can see in our TeamSort algorithm program, we choose the alphabetical sorting criteria. We enter 4 students with their names and exam scores. At the bottom, you can see the final sorted student records by name or alphabetical arrangement. First, we have ACQUIATAN, followed by BALBIRAN, followed by BILAY, and last is SOBIACO. But how does TeamSort algorithm works? Let's find out together. To start our simulation, we inserted 4 students. This is where the insertion sort is taken. So we have inserted BALBIRAN with 87, SOBIACO with 85, BILAY with 91, and ACQUIATAN with 89. So we have created our unsorted list. So in order to proceed, we will divide the unsorted list into 2. So BALBIRAN and SOBIACO will be grouped, while BILAY and ACQUIATAN will be the other group. As you can see, we divided our list into 2 segments. We will repeat it again with the same procedure and divide it into an individual segment. Now we divided our list into 4 parts. This is where the merge sorting takes place. And now the algorithm will compare each data to one another. So BALBIRAN will compare to SOBIACO and BILAY will compare to ACQUIATAN. The algorithm will only read the first character of each data. So as you can see, we have BALBIRAN with the character of B and SOBIACO with the character of S. So if we compare in the alphabet, so B will come first followed by S. So when taking place in the merge sort, so BALBIRAN will take place followed by SOBIACO. So in the other set of the data, we have BILAY with letter B and ACQUIATAN with letter A. So same procedure, and ACQUIATAN will take place and followed by BILAY. So as you can see, we have merged into 2 segments. And now we have 2 sets of unsorted lists, and we will do it again with the same procedure. So each data would compare each first character. So we have BALBIRAN with the letter B, SOBIACO with letter S, and ACQUIATAN with letter A, and BILAY with letter B. Since ACQUIATAN has the first letter of the alphabet, which A, she will take the first place of the list. Since we have 2 same characters from BALBIRAN and BILAY, we'll proceed to the second character of each data. For BALBIRAN, we have A, and for BILAY, we have I. If we compare A and I, so A will come first followed by I. So if we insert it in the list, so BALBIRAN becomes second in the list and followed by BILAY. Since SOBIACO is the remaining data with the character of S, the algorithm will put it in the last part of the list. In our simulation, we use the TeamSort algorithm by sorting the alphabetical arrangement. So the output is the same from our program. We have ACQUIATAN with 89, BALBIRAN with 87, BILAY with 91, and SOBIACO with 85.
After JAYSON organized the data in alphabetical order, now we will proceed in organizing data according to the ranking score. The question is how? So we have here a group of students who already have a score. We have BALBIRAN with 87, SOBIACO with 85, BILAY with 91, and ACQUIATAN with 89. We will divide it into 2 segments. First segment, we have BALBIRAN and SOBIACO. Second segment, we have BILAY and ACQUIATAN. BALBIRAN with 87, SOBIACO with 85, BILAY has 91, and ACQUIATAN has 89. Next, after dividing it into 2 segments, now we will arrange them according to their score. TeamSort starts by finding the longest increasing subsequence, which in this case we have BILAY with 91 compared to the first segments, we have BALBIRAN with 87, but because BILAY has the longest increasing subsequence, BALBIRAN will be replaced by BILAY. And repeat the process in comparing the 2 segments until you organize its data. Therefore, the sorted arrangement using team sort is: rank 1 is BILAY with 91, rank 2 is ACQUIATAN with 89, rank 3 is BALBIRAN with 87, and rank 4 is SOBIACO with 85.
Overall, the team sort algorithm is a valuable tool due to its efficiency, adaptability, and broad applicability. Understanding its importance can help you choose the right sorting algorithm for your specific needs and optimize your performance and solve your problems. That is all, everyone. Thank you for watching.